This is a reintroduction to exponents. It hopefully will not take too much of your time, but it will jog your brain of some very important ideas. First off, exponents really are just a repeated multiplication. So a to the power of n is simply a series of a's being multiplied together. How many a's? N of them. So we have n factor of a's being multiplied together. So the next exponent law would be the product of powers law. A to the power of n times a to the power of n is equal to a to the power of m plus n. So in other words, if the bases are the same and you're multiplying it together, simply add the exponents. The quotient of power laws. Whenever it's a to the power of m divided by a to the power of n, you simply subtract the exponents, a to the power of m minus n. And really, if you want to convince yourself of this, you should write the example 2 to the power of 7 divided by 2 to the power of 3. Write them out in expanded form and you'll see that the n part is just simply the common factors of a. Combining bases, if ever you need to combine bases, what we notice is though the condition that you must have is the same exponent. So a to the power of n times b to the power of n is equal to a times b to the power of n. We can write the nth root as a rational exponent, 1 over a. Keep in mind that the square root, this n part on our radical, is called the index. When we take the square root, that index is 2. Although we don't write 2, that index is there. The reciprocal is denoted as a negative exponent, so 1 over a to the power of n is written as a to the power of negative n. Now combining a series of exponent laws together, we can get this complicated expression that I'm sure you're familiar with, grade 9, grade 10, and maybe a little bit of grade 11. Let us continue. We're going to write 8 root 32 as a power of 2. My first step is, this is the way that I treat it. I like to see these two quantities expressed in as a product. Now I'm going to change 8 and 32 into base 2. So 8 can be represented as 2 to the power of 3. 32 is 2 to the power of 5. Now the square root is equivalent to the exponent 1/2. So really, 2 to the power of 5 to the power of 1/2. So right now, on the right, the term on the right-hand side, 2 to the power of 5 to the power of 1/2, this is a power to a power, so what we're going to do is we're going to multiply the exponents. So an exponent to exponent, we multiply the exponent. Now what we have is common bases that are being multiplied together, so we simply add the exponents. 2 to the power of 3 times 2 to the power of 5 over 2. Really, it's 3 plus 5 over 2, which is 11 over 2. Let's continue on with another example. Just give it a second, maybe press pause, give it a second. How would you proceed? I'm glad you're joining me from your unpaused moment. The way that I proceed may be different from the way that you would. However, both are likely to be correct. I would consider this as a product of two factors. One of them is 25, the other one is 1 over the root of 125. Likely my next move is to change both of these integers into base 5. So 25 can be written as 5 squared. 1 over root of 5 cubed, right? Because 125 is 5 to the power 3. Again, I notice that I'm taking the square root of a number, So I simply raise 5 to the power 3 to the power of 1/2. So I just simply apply the operation, multiply my powers in the denominator. I take the reciprocal, right? It's equivalent to a negative exponent, so 1 over 5 to the power of 3/2 is the same as 5 to the power of negative 3/2. Now, these two bases are the same. I'm going to be multiplying these two quantities, so when the bases are the same, I add the exponents. 5 to the power of 2 times 5 to the power of negative 3/2 is 5 to the power of 1/2. I hope this helps jog your memory on previous learnings. If you have any questions, feel free to ask.